Right now, hidden inside your kitchen cabinet is a combination of two things that can generate real, usable electricity permanently. No solar panels, no battery pack, no monthly energy bill attached to it, just salt, water, and two pieces of wire. And the reason you have never been told this, the reason this information has been buried beneath decades of corporate advertising and energy industry lobbying, is that it works. It genuinely works. Professionals will charge you hundreds, sometimes thousands of dollars to keep your lights running, your devices charged, your home dependent on a grid that was designed not to serve you, but to bill you. That ends today. The energy industry, and make no mistake, it is an industry before it is a utility, has spent the better part of a century perfecting one thing: your dependency. The average American household spends over $1,500 a year on electricity. British households are now paying record rates with energy bills that have doubled in under 3 years. And the moment you ask why, the moment you start searching for alternatives, you are met with a wall of complexity, regulation, and misinformation deliberately designed to make self-sufficiency seem impossible. You are told you need expensive solar arrays, complicated inverters, grid tie systems that cost $10,000 before you generate a single watt. You are told that without professional installation, you are dangerous to yourself and others. You are managed, you are controlled, you are milked, but that changes today. By the time this ends, you will understand the exact electrochemical process that turns salt water and two dissimilar metals into a functioning electrical current. You will know where to get everything you need for under $5. You will have a clear, step-by-step process that anyone, regardless of their technical background, can replicate at home today. And you will understand why this method, despite being grounded in 19th century science, has been kept out of mainstream conversation for over 100 years. Stay with me, because the next part changes everything, and I will also show you the one critical mistake that causes this entire system to fail silently, leaving people convinced it doesn't work when it absolutely does. This is not a new discovery. That is perhaps the most important thing to understand. The principle behind saltwater electrical generation was documented in scientific literature as far back as 1799, when Alessandro Volta, the man whose name is stamped on every battery you have ever purchased, first demonstrated that two dissimilar metals submerged in an electrolyte solution produce a measurable electrical current. He called it a voltaic pile. The scientific community called it revolutionary. And for a brief, remarkable moment in history, it looked like decentralized, self-generated electricity might become the foundation of modern civilization. It didn't, because within decades, industrialists recognized that a world where individuals could generate their own power was a world where they could not build empires. By the late 1800s, the commercial push toward centralized grid power was already underway, backed by capital, backed by lobbying, and backed by a very deliberate effort to make the voltaic principle seem primitive, outdated, and insufficient for modern needs. Textbooks reduced it to a classroom curiosity. Science fairs kept it as a lemon battery demonstration, and the public was guided, systematically, toward the understanding that real electricity required real infrastructure. What they never told you is that the underlying science never stopped working. Researchers working outside of industry funding, in university basements, and amateur electronics communities, and off-grid survival circles, continued refining the saltwater cell concept for over a century. By the mid-2000s, several independent engineers had documented configurations capable of producing sustained low-voltage current, sufficient to power LED lighting indefinitely. The energy industry noticed. The conversation was buried. And this is where it gets interesting, because what I am about to show you, the specific configuration, the exact materials, the reason this works at the molecular level, this is the part that took researchers decades to figure out. The part that the industry spent considerable effort making sure would never reach a mainstream audience. Most people, even those who stumble onto this topic, stop at the surface level. They try it once, get it wrong, and walk away. Don't. The solution is called a galvanic cell. And in its saltwater form, it is one of the most elegant and misunderstood power sources in existence. Here is why it works, stated plainly. When you submerge two different metals in salt water, something happens at the atomic level that the textbooks gloss over. The salt, sodium chloride, breaks apart in water into charged particles called ions. Those ions become a pathway, a conductor, through which electrons can travel. But electrons need somewhere to go, and this is where the two dissimilar metals matter. Different metals have different tendencies to give up their electrons. This is called their electrochemical potential, and every metal has a measurable value on what scientists call the galvanic series. Copper holds its electrons tightly. Zinc gives them up readily. When you connect copper wire and zinc wire through a saltwater solution, zinc begins releasing electrons almost immediately. Those electrons flow through your external circuit, through your wire, through your light, and return through the copper. That flow of electrons is electricity. not metaphorical electricity, not trickle electricity. Measurable, real, usable electrical current. A single well-configured saltwater cell produces between 0.8 and 1.1 volts. Stack multiple cells in series, and you begin to approach the voltage needed to drive a modern LED light continuously. This is not theoretical. This is Ohm's law. This is chemistry. This is physics. And it is available to anyone willing to spend 5 minutes understanding it. If you have spent any time on this channel, you already know that we do not report on stories the mainstream wants you to hear. We report on what they'd rather you didn't. If that matters to you, if knowing the truth before the crowd does matters to you, then consider staying with this community. What comes next is the part most people never reach. Here's exactly how to build a functioning saltwater electrical cell. You will need the following: a glass or plastic container. A mason jar works perfectly. Table salt, non-iodized is preferable, though standard table salt will function. Clean tap water, a length of solid copper wire. The kind used in household electrical work, 12 or 14 gauge, available at any hardware store for under $3 per foot. And zinc-coated steel, galvanized nails, easily purchased in any hardware or DIY store for pennies, are ideal. You will also need a small LED light, the kind rated for 1.5 to 3 volts, available in bulk online for under $1 each. Begin by dissolving 3 to 4 tablespoons of salt into approximately 1 liter of water. Stir until fully dissolved. You are creating a saturated electrolyte solution. The denser the ion concentration, the more conductive the pathway. Pour this solution into your container. Next, take your copper wire and shape one end into a coil. This increases the surface area in contact with the solution, which directly increases current output. Submerge this coil into the salt water, leaving the other end of the wire above the surface. Do not allow the above surface end to contact the water. Now take 2 galvanized nails and submerge them in the solution on the opposite side of the container from the copper. Connect the nails together with a short piece of wire so they act as a single zinc electrode. You now have the 2 electrodes, copper as your positive terminal, zinc as your negative terminal, submerged in an electrolyte. Connect your LED between the copper wire and the zinc nail wire. In a single cell, you will see a dim glow. This is your proof of concept. Now, here's the critical step that most people miss. And this is the mistake that causes people to give up entirely. A single cell produces roughly 1 volt. Most LEDs require a minimum of 1.8 to 3.2 volts to emit visible light. If you use only 1 jar, 1 copper electrode, 1 zinc electrode, you will measure voltage but see almost no light. The solution is series configuration. Build 4 identical cells. Connect the negative terminal of cell 1 to the positive terminal of cell 2, and so on, the same way batteries are connected in series in a flashlight. By the time you connect your LED across the combined output of 4 cells, you are working with 3 to 4 volts of sustained current. The light will illuminate continuously, without any input from you. One additional warning: do not allow the copper and zinc electrodes to touch each other inside the solution. This creates a short circuit that drains the cell instantly and produces no usable current. Keep your electrodes separated, parallel, and never in contact. Before wrapping up, and most people watching this far have already earned the right to know this, there is one more thing about this setup that almost nobody discusses. The saltwater cell does not just power lights. With the right LED configuration and a simple charge controller circuit, available online for under $8, the same series array can be used to trickle charge a small capacitor bank, which in turn can power low-energy electronics, small radios, USB charging, sensors, timers. The same principle that Volta demonstrated in 1799 is, with modern components, a genuine off-grid micropower solution. Hobbyists in rural Southeast Asia have been using variants of this system for years to power nighttime LED lighting in communities without grid access. The technology has been there all along. The awareness has been the missing piece. Now consider what the alternatives cost. A basic solar panel kit, entry-level enough to power 2 LED lights, runs between $80 and $150 before you factor in battery storage, charge controllers, and mounting hardware. A professional electrician called out to assess your off-grid options will charge you a consultation fee before they sell you a system that puts them on commission. The saltwater cell array capable of powering 2 LED lights indefinitely. Materials cost, under $6. Replacement cost when the zinc electrode eventually degrades, because it will, over weeks to months, depending on usage, is the price of a packet of galvanized nails. Compare that to your monthly energy bill. Compare that to the $400 average call-out fee for electrical work in the United States. Compare that to the quiet resignation most homeowners feel every time their utility company announces another rate increase, and there is nothing they can do about it. There is something they can do about it. There always was. The old method, Dependency on grid power, on professionals, on systems designed to extract money from you month after month was never your only option. It was simply the only one you were shown. This solution works. The science is unambiguous. The cost is negligible. And the satisfaction of watching a light run on nothing but salt and water, a light that no utility company can bill you for, that no blackout can extinguish, that requires nothing from any corporation on Earth, that is something the energy industry has worked very hard to ensure you never experience. You have experienced it now. But here is what is worth considering as you sit with that knowledge. The saltwater cell is not the end of this story. It is the beginning, because the same electrochemical principles at work in your mason jar are also at work in a far larger, far more powerful phenomenon that engineers have been quietly studying for decades, one that does not require any materials at all, only naturally occurring conditions in your immediate environment. We will get to that. There's a reason the energy companies are not just indifferent to what you learned today. They are actively opposed to what comes next. The question is not whether this technology exists. The question is, how long have they known? And why exactly have they never wanted you to ask?